Welcome back to NLP Track. Myself Farsana. So far in Word2Vec, we discussed about what's happening in behind the screen. Now what we are going to do is how SpaCy does vectorization, how Word2Vec generates. If you are new to SpaCy or Word2Vec, please refer previous tutorial to understand the concept. Before we dive into today's session, if not yet subscribe my channel, please do subscribe. If already subscribed, please hit the bell button so we will not miss the upcoming videos. Do you know one thing? Basically, SpaCy by default uses 300 word embedding. To know how, let's start importing with the necessary libraries for today's session is SpaCy and Pandas. The next step is to download the model EN Core Web MD. MD is nothing but the medium size. To understand this process, please refer previous tutorial. Link will be highlighted in description as well. Once it's successfully downloaded, the next step is to link the model ENMD by using the keyword link, which says that the model is already linked, nothing to worry. So we'll go for the next step. To know what is all about ENMD, just pass the keyword info. Info is nothing but the information, which says that this is a model belongs to license property of MIT. The version is 2.3.1 and the pipeline which is got trained here is tagger, parser and named entity recognition. To understand about this, please refer previous tutorial. The next step is to load the model ENMD. Now let's find the similarities between the documents. The first example here is for the document 1, no SIM card was included. Finally got a SIM from carrier and the phone has to be power cycled numerous times to even make a call. The second document is ordered for my in-law. It was carrier locked to simple mobile, but that's what I was looking for anyways since we activated with them. Seems both are opposite review. The first one is a negative and the second one is the positive review. Now we find the similarities between the document 1 and 2. For that, we have to use the keyword similarity. So the similarity between the two is 0.95. Even though the review are totally opposite, it is 0.95. The reason is we are not doing any sentiment analysis. We are doing only the similarity, and the reason is high because the context is same. That is iPhone, mobile, SIM, and carrier. To understand better, we go for one more example. Here we have two statements. I like to eat apple daily for breakfast. I like everything from apple when it comes to phone. And here the similarity is 0.85. The reason is even though apple is same word, the context is different. That is the reason it ended with 0.85 and not with 0.95. One more point to highlight here is always we have a challenges when we work with a proper noun. For example, when we want to find a similarity between the common nouns such as apple, orange, fruit, between fruits, okay, there is no issue. But when we want to find the similarity between the proper noun like iPhone, Samsung, always there is a challenge. Not only with SpaCy, even if you work with any other pre-trained model, there will be a challenge. Next experiment is we take two sentences and we compare word and every word in a sentence. Here for the review 1, the burger was small and did not have lettuce. For the review 2, the chicken was moist, juicy and spicy. It is worth spending some bucks. So what we are going to do here is I am taking a token of word E. I am going to compare each word in this review. To do that, we have to pass the loop condition. For that, what I am using a for I in review 1, passing a condition only if the similarity, if token 1 dot similarity is greater than 0.4, I am popping out the output. So here how the similarity is calculated, let's see. I did eat. I did not eat. I have to eat. I am eating lettuce. This is the power of Word2Vec. See how SpaCy think out of the box. And one more point to highlight here is there is no training happening. Just we are reusing whatever SpaCy has learned on medium corpus. Now let's examine with the one more example. Here we are doing with the review one, and I am popping out with the similarity only when it has more than 0.5. Now it just popped out only chicken, no other words. The reason is we made a condition of 0.5. Suppose we want to add this moist, juicy and spicy, means we want to change this accordingly. When I changed to 0.3, we just got almost all similarity words. So far we learned token versus token, document versus document, and even token versus token in a document. Now the next experiment is token and document. But before we jump into this example, SpaCy can also average out all words in the document. For example, if a document contains 30 words, each of a word has a word vector. Now in order to get the document vector, it will just average out of the word vector. But no need to make it complicated. Anyhow, we will learn this in transformer session in detail. At present, imagine this is just an average out. So here our example is for the document, Sherry likes donut, and the token here is waffle. Now the comparison similarity between these both is 0.44 because both are coming under double. See here, once the data are converted into vector, we can make it dance. That's what we are doing here. The next experiment is between span and document. Now a bunch of token with a document. Here the example is I like pizza and pasta. I am going to take the word only pizza and pasta. That is the reason I am passing the position between 2 to 5, because I like it not make any sense when it's come to eatable one. And the next one is McDonald's sells burger. So now we are comparing the similarities between the two. It's almost 0.61. Now the next experiment is vector of word. To see the word vector behind the screen. So this is the average of word vector for all 5 words in the sentence. Okay. Suppose if I want to find the vector only for one word, for example, I want to find the vector for this burger, what I want to do, just pass the position. Okay. So this is with 1. The first one is 0, the second one is 1. So this will give the vector for the token beggar. This is the beauty of the vector. So far we learned whatever there is in the vocabulary. Suppose if the token is out of vocabulary or whether it's in vocabulary, how to find out, that is what we are going to do. Example here, we took Farsana, the weather is fantastic, we can go on road trip. I am just executing it. As already highlighted, Farsana is a name which is a proper noun. It is not having any vector. So here token.text will display the text. Token.has vector, it will highlight whether this token has a vector or not. So Farsana is a proper noun. So there is no vector. So it displayed as false. And for the remaining, even for dot, we have a vector there, whether everyone has a vector. The next one is vector underscore norm. Already we highlighted that each word has a 300 dimension, which is a 300 word embedding. Okay, so we have 300 number. So to find a single number, what we want to do is just pass the keyword vector underscore norm. So for the word there, it has a vector norm of 4.7. But how come from 300 it chose 1? Let's see how the single value got updated. The reason here it uses the L2 normalization, which is nothing but the equidistant distance. Now let's understand this calculation behind. We all know that it's a 300 dimension. Now for simplicity, I am taking only a 2-dimension word embedding. Suppose for a word, okay, now eat, it has a embedding of with 3, 6, just for an understanding. So Euclidean distance is nothing but distance between the origin and the vector. Formula here is the square root of 0 minus 3d whole square plus 0 minus 60 whole square, which is nothing but the 3 square 9 plus 36, which is the square root of 45. This is what the L2 normalization. So here calculate the equivalent distance between the origin and the vector. And we also have other normalization, nothing but the L1 normalization, which takes the absolute value of 0 minus 3 plus 0 minus 6. This is how the value got normalized from 300 to 1. But in reality, we use all, in reality we use all 300 dimension vector. So this is how SpaCy works. We will also see how SpaCy word vector work in case studies going forward. Okay. So this is all about the today's session. If you like, please do like, share and subscribe. Stay tuned for the next session. Till then, Farsana signing off.